This podcast will be the last lesson in the unit on relations and functions and characteristics of linear functions. And it should be hopefully a quick lesson. The entire lesson is on a concept that you already know from junior high. So the concept is on parallel and perpendicular lines. And then how it's going to become new in high school is we're going to be looking at the slope of parallel and perpendicular lines. So the first thing that we need to be able to do is before we could figure out slopes, you need to understand what a parallel line is and what a perpendicular line is. So I'm going to pause, or I want you to pause this, and I want you to write this down. So that's going to be your definition of lines that are parallel. And then I want you to write for perpendicular. Here's what I want you to write for perpendicular. So take a minute, write that down, pause this, and then I'll go through it. Okay, so what my definition of parallel line says, it says that there are two lines on a plane which do not meet. So if you extend these two lines forever, so let's say it was that line and this line, pretend that those are parallel. They don't look completely parallel. But if I extended these two lines forever and they never meet, these two lines would be parallel. Now, in high school, we have to tie this into slope somehow. So how are we going to relate this to slope? It's very simple if it's parallel. If I told you that the slope of the blue line is 2/5, and I said, well, what's the slope of the pink line? It's easy. If it's parallel, the two lines would have the exact same slope. So if the blue line has a slope of 2/5, they're parallel, then the pink line would have a slope of 2/5. So for parallel lines, what you need to know is that the slope of line 1 is equal to the slope of line 2. So if I give you a line and I give you the slope and I say, well, what would the slope be of a line parallel to it? They're identical. Perpendicular, there's a little bit of work we have to do to it, but it's still easy to figure out. So first of all, for perpendicular, we need the definition. It's lines that intersect at a 90-degree angle. So these two lines here would be perpendicular. Now, a couple of things. Parallel, we said that the slopes are equal. Obviously, for perpendicular, these are not going to be equal slopes. So for this purple line, if I just said, well, would this be a positive, negative, zero, or undefined slope? You're going up the hill, so this purple line would have a positive slope. This green line, you're going down the hill, would have a negative slope. So the first thing that I want you to see is that for perpendicular, you're always going to have one slope that's positive and one slope that's negative. Flip to page 539, and I'll go through again how we're going to calculate parallel and perpendicular. So it says here, so star this, that the lines are parallel if they have the same slope. So slope of line 1 is equal to the slope of line 2. They're going to be parallel. For perpendicular, what I want you to write down is that they are negative inverses of each other. Okay, so what does that mean, negative inverses of each other? Let's say I gave you that the slope of line 1 was 2/5. And then I said, what would a perpendicular slope to this be? Well, what we do is if it's perpendicular, you need to take the inverse of 2/5. The inverse is just essentially the reciprocal, or flip this. So the inverse of 2/5 is 5/2. And then remember, with perpendicular, one slope is always positive, one slope is always negative. So if this was positive, this guy would have to be negative. And these are what we call negative inverses of each other. Okay, let me give you another example. So if I said that the slope of line 1 is equal to negative 2/3, what would a parallel slope to this be? Parallel means the same slope. So parallel would be the slope of line 2 would be negative 2/3. If I said, well, what's the perpendicular slope? You would say, okay, slope of line 2 is equal to, it's the negative inverse. So take that guy and flip it, which would be 3 over negative 2. If this was negative, then the perpendicular slope would have to be positive. So I'm going to erase the negative. And these are what we call negative inverses of one another. One of them is negative, one of them is positive, and they are inverses of one another. I'm going to give you one more example, and I want you to write this example down. What if I said slope of line 1 is equal to negative 4? Okay, could you find the parallel slope of that for me? So parallel slope would be equal, right? So if it was parallel, the answer for line 2 would be negative 4. If it was perpendicular though, and I said, okay, well, what would the perpendicular slope be? So we know that we have to take the inverse. So the inverse of negative 4 over 1, if I flip this, it would be 1 over negative 4. And then if this was negative, this guy has to be positive. So these two would be perpendicular lines. If I have the slope of one line is negative 4, then the perpendicular line to that would be 1 over 4. Okay, so what are examples going to look like? So it's going to look like class example 1, and there's only going to be 3 class examples that we'll do, and then I will give you your homework. So for class example number 1, it says consider line segment AC with a slope of 3 over 4. So let's write that down. Slope of line segment AC is equal to 3 over 4. Write a slope of line segment GH if it's parallel to AC. Parallel means equal, right? Slope of line 1 is equal to the slope of line 2. So sorry, there's just an announcement going on. Okay, sorry, just to finish that, if they're parallel, they're equal. So if one slope is 3/4, a parallel slope would be 3/4. Okay, now they want line segment BF, which is perpendicular. So the first thing I always do is write the line segment of AC. So line segment of AC was 3 over 4. Now they want the line segment of BF. So slope of BF. If they're perpendicular, perpendicular is negative inverses of one another. So the inverse of 3/4 is 4/3. If this was positive, this has to be negative. So these are negative inverses of one another, and then that would be your answer. The slope of BF is equal to negative 4 over 3. Class example 2. The slope of two lines are given. Determine if the two lines are parallel, perpendicular, or neither. Slope of line 1 is 1/4, and 3 over 12 is slope of line 2. So first thing I have to do is I have to reduce 3 over 12. So if you need to, you could punch that into your calculator, math one fraction, but that is going to be equal to 1/4. So if I have a slope of 1/4 and a slope of 1 over 4, the slope of 1 is equal to the slope of 2. Therefore, these two line segments, what are they? Parallel. Okay, let's do this. B, slope of line 1 is 5 over 7. And slope of this guy is 14 over 10. If I reduce this is 7 over 5. So some people would be like, oh, 5 over 7, 7 over 5, those are inverses of one another. It's perpendicular. However, let's think about this. Slope of line 1 is 5 over 7. If I said what's the inverse of that, you would say, okay, slope of line 2 would be 7 over 5. But if this is positive, this is negative. These two would be perpendicular lines. So these two slopes would be neither, right? because in order for that to be perpendicular, I'd need a negative there, but there is no negative. So the answer for B is neither. I was going to get you to pause it and do 3, 4, and 5. You could, or I'll quickly finish off this last example and then I'll give you your homework questions. So what it says for example 3 is it says if point P is this and point Q is this, what's a parallel line segment to PQ? So first of all, we need to apply something from the last lesson, and I need to be able to find the slope of PQ. Okay, so slope of PQ from the last lesson, the equation or formula for slope is y2 minus y1 over x2 minus x1. So if you're given 2 points, this point is x1, y1, this point is x2, y2, and let's figure out the slope of PQ. So slope of PQ is equal to y2 minus y1 over x2 minus x1. Slope of PQ is negative 9 over 6 minus 4, which is 2. Okay, so going back up here, the slope of PQ is negative 9 over 2. They want the slope of a line parallel to PQ. So the slope of a line parallel, remember if they're parallel, they're equal. So the answer would be negative 9 over 2. Now, what's a line segment perpendicular to PQ, right? Perpendicular is negative inverses. I would need to take the inverse, which is 2 over negative 9. But if this was negative, this has to be positive. So I'm going to come in and I'm going to erase that negative. And that would be my perpendicular slope. This would be my parallel slope, and that would be my perpendicular slope. Okay, homework questions that I want you to do. So we're not going to do class example 4 or 5. So for homework, I want you to do 3. And for 3, we're just determining if they're parallel, perpendicular, or neither. Remember that you need to reduce your fractions, right? So always, for number 3, reduce your fractions. So 8 over 20 is not reduced. If you reduced 8 over 20, that would be 2/5. So 2/5 and 2/5, those are identical slopes. This would be parallel, right? So don't forget to do that. If I was to jump down to G, I have 4 over 8. So slope of AB, if I reduce that, that is 1 over 2. Slope of PQ is equal to 2 over 1. So yes, these are inverses of one another, but they're both positive, right? In order for it to be perpendicular, one has to be positive and one has to be negative. So this would be neither. So do all of question 3, do all of question 4, question 5, the slope of some line segments are given. Which pairs are perpendicular to each other? So how I would do number 5 is, for example, if the slope of this is negative 2 over 1, write down what the perpendicular slope would be. So the perpendicular slope would be 1 over 2, right? So if that's negative, this guy would be positive. And there is no, oh, 1/2 right here. So RS and EF are perpendicular to one another, right? Figure out this guy, UV. So 1/4 Perpendicular to this would be -4/1. So this would be perpendicular to this, right? And then your last class example, number 5, it gives you 3 different points. And what it says is determine the slope of a line parallel to AB. So the first thing you have to do is you first have to figure out, well, what's the slope of AB? So this is point A, B, and C. If I said what's the point or slope of AB, x1, y1, x2, y2. So you would have to calculate the slope of AB, and then parallel means identical slope, right? For C, you need to find the slope of BC. Minus x1. So what you're going to do is I'm going to erase this. And if I'm figuring out the slope of BC, I would call this guy x1, y1, and this guy x2, y2. Okay, so this would, number 7 would be sort of your most challenging question, but see if you're able to do that. And that concludes the last lesson for this unit.